Hello, and welcome to our program, Astronomy for Everyone. The topic of this month's program is the Michigan Meteorite. And here in the studio with me is Tony Licata to tell us all about this exciting event. Tony, welcome back to the program.
Hi, Don. It's great to be here.
Well, what can you tell our viewers about how you found your first meteorite and the others?
Well, first of all, I have to say, meteorite falling locally has been always a dream of mine. It has to be one of the most exciting things that's ever happened in my life.
Besides getting married and having a family, of course.
Yes, of course.
Yes, in case the wife is watching.
But being into astronomy since a teenager, I recall evenings out in Hamburg Township, where I grew up, thinking about, as I watched the Perseid meteor showers and other events unfolding, what it would be like if a meteor would actually fall and whether you'd be able to find them. Now, normally the Perseids don't hit the ground, but this particular one did. And right there, just as I imagined as a kid, right there in Hamburg Township, a meteorite actually fell to the ground. A meteor actually fell to the ground. And people began finding these rocks in the strewn fields. So what an exciting thing to happen, and how rare is that?
Exactly. I know online there's a whole bunch of different videos as it went across, lighting up the sky and the boom that followed. I was down the basement, didn't see or hear a thing, but I've seen a lot of the videos, and it is truly a very exciting event.
Yeah, so I was actually up north, at my place up north. It was a new moon, so I was doing astronomy up in dark skies. And exactly. I stepped out to check the weather because it was freezing, biting cold that night. And I wanted to check the temperature, so I stepped out of the observatory. And that's when I saw a flash. From 200 miles away, I noticed a strange flash. I thought some headlights must have gone by, but that never happens up there. It's a pretty remote site.
Okay.
So I thought, what was that flash? And didn't think anything more of it until I went inside about an hour later and began to read the email reports coming out on the subject. So
there was a particular comment that somebody had to say?
Yeah. People began emailing in the Astronomy Club. I'm part of a local club in Farmington Hills, where I'm living now, called the Farmington Community Stargazers.
Oh, yes.
And they have a little email list. Todd Slisher, who was the one who organized the team, was part of that list. And so he began mentioning that this was a meteorite, and some of the Ford Club members were also reporting out that something fell and hit the ground. And the initial reports was it was in Port Huron or something like that.
Okay.
But what happened is Todd had a security cam in his backyard, right? And as the meteor went over, you can see here in the display, the meteor went over. It cast a shadow across his deck, and so the shadow just transited the base of his deck, which is a nice level surface on which to measure a line. The peak of his roof transited the deck from point A to point B. You can see the triangle there. Todd doesn't actually have a triangle constructed on his deck like that. He drew that on, and but measured those legs and did some simple 8th grade math to calculate where this thing came in. So he actually got a rough trajectory, which is in the little shot above, and you can see his scribbled calculations there.
Sure.
How he determined before NASA even, that this thing was coming in closer to Hamburg Township and not Port Huron.
Okay.
So the next slide, we can see what this data came out from. This was the actual NASA data. This is by Mark Fries, who actually learned how to use weather mapping, Doppler radar, to project where meteors are actually falling. Doppler radar actually picks up meteors.
No kidding.
And they began to map where they would have fallen. So this is when Todd's calculations were confirmed. And when this happened, then that's when we began to organize a search team and go out to Hamburg. And that happened this came out on the 17th. This was January 17th. And on the 18th, we hit the fields and started looking. So,
sure.
Yeah. So
and there you are in the fields.
And we started out on land, but we moved our search later on out onto the lakes. So these are some of the lakes in Hamburg Township. And there's Todd on the left.
Yeah, my old boss at the Detroit Science Center.
Yeah. And he's now up at Longway Planetarium. He's director there. And he found the first rock, which was a 12 millimeter specimen. And we weren't quite sure if it was a meteorite because all of us were pretty amateur at finding meteorites. Todd is the only one that actually was on a hunt, but never found any on that first hunt.
I know he's knowledgeable about meteorites.
He is, very. But as far as hunting for them,
well, yes.
We were all kind of new at it.
Okay.
And so we weren't sure what kind of meteorite fell, first of all.
Okay.
And where we might find them. But so we hit the lakes, and Todd did find the first black rock. It looked like it had a fusion crust on it.
Okay.
And so then the next one to find one was me, and I'm standing there in the shot emailing my wife. And then the guy in the middle, that's Brian Wolf. He found the largest specimen.
Oh, okay.
But that was actually the third one. They're not in order. But that next shot, then we moved back to the cottage where, that's my place on the lake, and displayed our rocks. And there's Sandra Masika, who was part of the team.
She's been on the show several times.
Yep, and she's a real meteorite expert.
Yes,
Unfortunately, she didn't find one of her own that day, but she was a huge help on the hunt. And there's Todd, who found the first 12 he's pointing. We're each pointing to the rock that we found. So there's the 12 millimeter, the 12 gram, and my 16 gram, and then Brian's massive 28 gram specimen, which was the last one we found.
All right, we've got our next shot.
Yeah, the next shot. So later, then we began to find other rocks. This is subsequent days, right? And I took my family out. That's my daughter on the left. That's Esther, and she found a beautiful little specimen, which I'd like to point to later, perhaps. And then my son found a whole bunch of specimens, all within a 12-foot radius out on the lake as well. He found my map. I was mapping the strewn field. I left it on the kitchen table. And he found the map and went out with his buddy and went right to where I thought there would be rocks. And he just kind of followed my trajectory, and they did find a whole grouping of them.
Great.
And those are the smaller ones that I have here in my display case. Then later, probably 12 days later, on the right, back one slide, is another team that Todd organized 12 days after the fall, where we found some on land. Okay, now you can go to the next slide, and we'll talk about some of the close-ups. So this is what the rocks looked like when they were sitting on the ice. They're called pictures in situ, which is a good thing to do for science, to
give some context.
Yeah.
Right. Mm-hmm.
Yeah, and so that's the one on the left is the first one Todd found. He already picked it out of the hole it was in. You can see the little divot it made. But these things hit the ice at probably 200 miles per hour and bounced perhaps once or twice and came to rest. And this is exactly how they looked when we found them.
It looks like in the middle image there, it looks like a little crystallization, like some of the snow had melted. That's how it appears to me in the picture. Maybe I'm wrong.
I think this was right next to one of the finds that one of the professionals who got there first.
Oh, okay.
And it was maybe a couple of feet away from a larger rock. But he would have missed this one. Perhaps it was under snow when they were on the ice in the morning. We got there around 3, 4 o'clock and began finding these rocks.
I see.
And so perhaps that snow just recently blew off and exposed the rock so that we could see it. Next one. So then later I mentioned we went out again with my family, and that's the in situ shot on the left of the one my daughter Esther found. Exactly how it looked. It was just a little black dot on the ice. I can't believe she spotted it, but sure enough, we picked it out of there, and it was a meteorite. Then 12 days later, I went out. Todd and I both had the same idea and built these little magnets on sticks, and we went out scanning the fields with magnets. And that's a 10 millimeter rock that I picked up on the magnet. We were actually headed back to the car after 5 hours of searching on land. We didn't find any, but then on the way back to the car, there was that rock, and it was broken side up. So it's a piece. There's a larger piece of that somewhere by the shape of it. There's a larger half of that rock still out in the field,
somewhere
waiting to be found. Yeah. Then some real close-up rocks so people can get a good idea of what these things look like. On the upper left is the specimens my son found out on the lake ice, and we picked those up with a magnet. And then lower left is the one my daughter found, highly magnified. But you can see it's got a convenient little chip out of the fusion crust.
Yes.
And you can see the light creamy colored matrix. And if you look into that, and then there's up on the upper right is the one I found. This is the first one I found out on the lake.
Okay. It looks like it's got a little piece broken off there as well. Where you
as
can
well,
see the
which is a nice window into the interior matrix of these rocks. And that helped us do some initial studies on them.
So you kind of touched on it a moment ago. Do you think there's more out there?
I do. I think there's more out there, and but they're becoming increasingly harder to find. The farther away you get from the actual fall date, the more difficult it became.
Well, if they were on the ice back in January, this is, we're recording this in April.
Yes.
So the ice is gone, and whatever laying there is now dropped to the bottom of the lake.
Exactly. So we've turned our search to land, and I can talk about that a little bit with some of the. But anyway, I'd like to maybe show the rocks. I have here a lot of the rocks we found. Not all of these are Hamburg meteorites, but this one is. This is the one my daughter found. This is the first one I found. The second one that I found on land.
From the left there, yeah.
Yes. You can go to this close-up shot. So the third one over here is now it's out for science.
We'll talk about that.
You're looking at
bit. Yep.
In this shot, you're looking at just a picture of it. But I'm going to get that back shortly. And the last one, it says Besicano. That's from a different fall, of course, not the Hamburg fall. And there's other meteorites in this case that I had previously.
As part of your collection.
Yeah, as part of my collection. But yeah.
We're going to take a quick break right here. And if you have any questions you'd like to email us, you can send it to the address that you can see down there at the bottom of your screen. And right after Term of the Month with Stephen, we'll be back about the Michigan Meteorite.
Thanks, Don. The term of the month is Image Gallery. You want to see some great pictures? Type nasa.gov in your browser and hit return. You'll get an image something like this. Along the top, those are drop-down menus. Click on missions and drag down to Juno mission at Jupiter. When you let go, you get to this image, which has a gray button bar, really, and I have selected, highlighted images. If you click on that, you get to an image gallery for the Juno mission. Pictures of Jupiter, they're all awesome. If you click on one, it gets bigger, and you get to go through other images. And that is the term of the month image gallery. Back to you, Don.
Thanks, Stephen, and welcome back. We're here with Tony Licata in the studio talking about the Michigan Meteorite. And so what are people saying about this find, Tony?
Oh, well, when we first found them, you mean?
Yes.
The comments range from utter disbelief, like when I was texting my sister there, they were just saying, no way, you didn't, no way.
Those are just rocks, right?
To what my brother said when we got him back to the cottage, my brother was saying, well, of course he found one. He's Tony. You know, he knows, he saw me out there night after night as a kid with my telescope. So he knows who I am and what I do. So, yeah, so from utter disbelief to, of course he did. Of course he found one.
Exactly, exactly. So can you tell us a bit about the science that's being done with the stones we call them from this fall?
Yeah, so of course some of the things that I've been doing personally is bringing these into the lab at OCC. That fellow there is Samer Hari. Hariri is how you pronounce his name. He's the geologist at OCC. And
Oakland Community College?
Yes.
Yeah, okay.
And he's on board with the American Meteorite Society, AMS, identifying these things, whether they're actually meteorites. So that's the first order of business is this a meteorite or not? And so when I find rocks, I bring them to him, and he will put them under the microscope and look for things like fusion crust and olivine crystals, which you see there in the magnified views. You can see he's looking into the little pieces that broke away from my two rocks and my daughter's rock below there. And inside you can see the little crystals of olivine and the melted fusion crust. And so it's that sort of thing that he looks for to positively ID these as.
So he knows it's a meteorite
Yeah.
and not a meteorong.
Yes, correct.
Yes.
And that's the first order of business. So the next thing we've been doing, if we can go to the next slide, well, once all of the work that the initial finders, we weren't the initial finders, they turned in all of this information, and what comes out, what happens first is the Meteorite Society will publish what's called a bulletin, and every meteorite fall gets this sort of thing. You don't have to read it. We can move on to the next one, but just so you know that they publish this bulletin which classifies the meteorite, and in our case, you see here the various types of meteorites. In our case, second from the left category is called ordinary chondrite. That's the category that our meteorite, it turns out, falls into. And we happen to be an H chondrite, more specifically an H4 chondrite, which is kind of how much iron content is in this. But what an H chondrite is basically a stony meteorite with some iron in it. And so that's the category we follow. It's an ordinary chondrite, so it's pretty common rock that falls.
Okay.
Most rocks that fall are chondrites.
And I noticed in the previous slide, which we don't need to go to, but it had the name Hamburg right at the top. So is that the name they're officially giving it?
Yeah, so once people were calling it the Michigan Meteor.
Like me,
right?
yes.
Yes, but when the official report came out, they like to name it after the nearest post office to where the fall took place. And that's Hamburg Township, where I grew up.
Which is just west of Metro Detroit, for folks who are
Yep.
watching this in other locations in southeast Michigan.
Yeah, but I was happy when I saw that was the name.
There you go. So they're looking into the science of this. We saw the fellow with the microscope. We've seen the report.
Yeah, so the next slide, though,
Yeah.
is some of the work that NASA's doing. So they go way beyond simple classification, and they're doing all kinds of studies. There's some cold work. Todd kept his sample in dry ice, right?
Okay.
And he sent, so they're going to do cold work and then after it's thawed work. So cold is preserving the pristine character of the rock as it came from space. So the good news is these fell in the winter on the ice, so they were kept cold. So they could do some very valuable science. I won't explain because I don't even understand what NASA's doing here, but all the different tests they do are illustrated in this slide that I got from Todd.
Would a meteorite typically go to NASA?
Yes.
Oh, okay. So this is a normal course of events.
And the Planetary Science Institute. So I've been contacted by the Planetary Science Institute.
Okay.
And I've sent my sample. That's why the one pictured here in my case is this one here is just a photograph of the one that I sent away to the Planetary
Sort of a
Science
placeholder
Institute.
till you get
So,
the original back.
Yeah. So they're doing their array of tests as well to the rock. And when all the science is in, we'll know a lot more about where this rock came from, what the parent rock was, how old it is. But the chondrites are generally some of the oldest meteorites. They're made of the substance that our universe was, or that our solar system was formed out of.
Okay, so yeah, at the very beginning, unaltered by Earth's geology and
Yes.
history over the last few billion years.
Yeah.
That's very interesting. So we've looked at the science here. What else can you tell our viewers?
Oh, well, the ongoing search, of course.
Okay.
We believe, as I said earlier, that there's more out there, but most of them, I think, are found. We're not finding as many as we thought we were, but this is pretty typical.
Do they have an idea how large the original meteor might have been?
Yeah, they're saying it's about 1 meter.
Wow.
Yeah, so there's only a tiny fraction of that that's actually been found, but a lot of it may have vaporized, but a lot of it may have fallen as dust. So I'm trying to find more and in the process map other sites
Okay.
to add to the strewn field. I built this little roller. It's a magnetic roller, and so I've been sweeping fields with permission, of course,
Sure.
from farmers, etc. We've been sweeping fields magnetically and picking up you know, schmutz we call it,
Okay.
which is those little fragments. We don't know if they're meteorites. I bring those to SAMR. It gets them under the scope, and
Okay.
some are maybes, some are definitely not, and some we're thinking are meteorites. And then other things we've been doing is, now there's no more ice, but we found places on the ice where there were some big holes, and we wondered what might have formed those, so we're dropping magnets down to see if we can find
You're not
there.
fishing for perch in there.
No, we're looking for the big one. So because of how much mass is still missing, we think it's
Oh.
still out there. So
Okay.
yes, there's more out there. Are they going to be easy to find? Absolutely not. It's going to be a tough go.
Okay, well, I guess you never know.
Yeah. The big one's probably in a swamp somewhere that'll never be found.
Yeah, unfortunately. Unfortunately.
It's not going to stop us from trying, though.
Maybe wait for the next fall here in southeast Michigan.
Oh yeah, right.
Yeah,
Like
yeah.
that's gonna. Don't hold your breath. This was a rare opportunity, and I'm excited to have been a part of it.
Have you been around the country to look in other areas, or just mainly localized?
No, I'm a rank amateur at meteor hunting, you know.
Oh, okay.
There's
Okay.
guys that do this professionally, and they get on the first jet out and get right to the site. And they're the guys that actually did find the rocks first. Even though I live right in Hamburg Township, those guys got there first because they know things like this Doppler radar data. When it comes out,
Yeah.
they're on the next flight out.
So they can
I didn't-
triangulate wherever. Yeah, okay.
I didn't know stuff like that,
Yeah.
but I had to learn as I go. So I think we did pretty good for
Yeah.
learning as we go. And the fact that we found 3 nice size rocks on the first time out, and subsequently found other rocks as well, I think we've done pretty well. We have a nice. We've added to the strewn field just in our local clubs quite well.
Great, and it's a great conversation to take to public outreach events
Oh,
with
absolutely.
the Farmington Club and
And with Ford Club.
the Ford Club too. Sure, other organizations, especially Astronomy at the Beach.
Yep.
Great place, which isn't too far from Hamburg, by the way, as I recall.
Yep,
So
it's not.
that'll be make for interesting times. I want to thank my guest Tony Licata for filling us in on this very interesting meteorite find here in southeast Michigan. If you like, please visit our website. We always like you to come to that. The address, as always, is down at the bottom of your screen. And coming up next with What's Up in the Night Sky is Stephen.
Thanks, Don. What's up in the night sky for May 2018? The sun rises between 6:28 and 5:59 in the morning over the course of the month, and it sets from 8:38 p.m. to 9:02 p.m. over the course of the month. Now, astronomical night starts and ends an hour and 50 minutes, at least in Michigan, before and after sunrise and sunset, respectively. The moon starts out on the 7th with the 3rd quarter. New moon on the 15th, 1st quarter on the 21st, and full moon on the 29th. Now, on the 1st of the month, we have Mercury, and you can see Mars on the upper right, but I'm going to talk about that a little bit later. Mercury is in Pisces through Taurus over the course of the month. It sets at 5:41, this is a.m., 5:41 in the morning, so we're looking here straight east to 5:41 by the end of the month. Mercury has this weird orbit, it happens. Then we have a whole series of planets in the night sky on the 8th. Neptune and Mars and Saturn and Jupiter. Actually, between Mars and Saturn, closer to Saturn a little bit, is Pluto. And way off to the left and slightly below the ground is Uranus. We're not going to be really talking about Uranus, but it is over there. Neptune is in Aquarius as always. It rises at 4:28 to 2:32 over the course of the month. So it's always getting, they're all rolling in that direction. Mars is in Sagittarius to Capricornus over the month. It rises at 2:07 in the morning to 55 minutes after midnight. Saturn is in Sagittarius. It is awesome all month, and that's because Saturn is in opposition in June, late June, June 27th, and it's an excellent object this month as well as next month. Jupiter has an opposition this month. It's in Libra. It rises at 9:02 p.m. to 6:46 p.m. over the course of the month. So it's basically up all night long, all month long. It is also awesome. This is the month for awesome Saturn and Jupiter. Jupiter has, this is the 8th of May, has the opposition on the 8th. We're not going to really talk too much about Pluto. It is in Sagittarius like Saturn, and so it really is in this picture. There's no dot. So we move on to Venus, and this is on the this image is from the 31st of the month. Venus is a little bit better at the end of the month. It goes from Taurus to Gemini over the month. It sets at 10:50 p.m., so that's almost 11, to 11:37 by the end of the month, so it's breaking the normal everything gets earlier thing, but Venus moves pretty quick. It can do that. It is best at the end of the month. That means it's farther from the sun. May has the Eta Aquariid meteor shower from the 4th to the 6th of the month. Now the peak is on the 5th, and it's in the morning. Unfortunately, we have a third quarter moon, and by the time the radiant rises, which is locally about 4 a.m., the moon has already risen a couple hours earlier, so the third quarter moon will be washing out some of the dimmer Eta Aquariids. The Eta Aquariids are better for the southern hemisphere. Sometimes the Eta Aquariids are in fact the best southern hemisphere meteor shower for the year. The southern U.S. is expected to see maybe 10 to 20 per hour this year. Remember to dress warm. Even if it's warm for you, it can be cold at night when you're not doing anything. And so that is what's up in the night sky for May 2018. Remember, we don't charge for Astronomy for Everyone, but we may tax your brain.